All right, so this is still the test 1 review. It's just part 2. Move that so you can see it. Okay, so we're going to start looking at system of equations. I did put quite a few systems on here just because I thought you needed some more practice with matrices. Okay, but 23 is not a matrix problem. It just asks you to take this set of equations and use the either the substitution or the elimination method. Okay, remember that method, substitution is where you solve for one of the variables and substitute that in. I don't think that would be easiest here. So I would probably do the addition/elimination method. So I'm underlining these because they're smaller, okay? So notice you want to find the biggest or the smallest number that both of these go into, right? So 6 would be the first thing. So I'm going to multiply this one by 2 and this one by 3, because notice that'll make that a -6 and this a +6, which is actually exactly what we want. So just make sure that you multiply all the way through by your 2 in the first equation, and make sure you multiply all the way through by your 3 in your second equation. So that's gone. So we get 30x equals 60. And so if we divide by 30, we have that x is 2. Okay, but that's not the final answer. That's only half of the answer, right? We actually need a full point. It's the point that they have in common, the x comma y point. So to find the y, we're going to plug in our x equals 2. So I'm going to use the second equation. So 4 times 2 plus 2 times y equals 14. But I could have just as easily used the first one. I just decided not to because the numbers were bigger, frankly. So I'm going to subtract 8 from both sides because 4 times 2 is 8. So I get 2y equals 6. And then divide both sides by 2, which will give us y equals 3. So how I want to see the answers most of the time on these systems is I want to see them as a point, and I want you to realize that it is literally the point that they have in common. So if you were to graph these two lines, the point that they would cross each other or intersect would be the point 2, 3. Okay, so let's look at 24. 24 is just a basic write that system as a matrix. So you're just going to pull the numbers. So if you read the first row, it is 1, 2, -3, and then remember we use a bar for the equal sign, and then 4. The second row is 5, -3, 1, 6. And then lastly 6, 8, -9, 4. All right, number 25 and 26 just has you practicing row operations. So 25, you are going to take the following matrix. I am going to write it down. And we're going to do -2 times row 1 plus row 2, sending that to row 2. And then we're going to do row 3 plus row 1, and we're going to send that to row 3. So remember, what's listed last is the thing that's changing, right? So that means row 1 is not changing. So we're going to pull row 1 over because row 1's making no change at all. And then I like to do the easy one first. So I'm going to do this one first. So row 3 plus row 1. So -1 plus 1 is 0. 4 plus 5 is 9. 6 plus -1 is 5. 3 plus 4 is 7. And then -2 times row 1 plus row 2, right? So -2 plus 2 is 0. -2 times 4 is -8, plus 0 stays -8. -2 times -1 is 2, plus 3 is 5. And then lastly, -2 times 4 is -8, plus -2 is -10. Okay, so 26 is similar. Remember that your goal with these row operations is usually to get a reduced matrix. And remember, reduced matrices look like ones in a diagonal and then zeros everywhere else. Okay, so I'm sending one of the changes to row 1. I'm sending one of the changes to row 3. So that means row 2 is not changing. So if you can just figure out what's not changing, you'll get some of the matrix right just from that. Okay, and then again, I like to do the easy part first. So row 3 plus row 2. So 0 plus 0 is 0. Negative 1 plus 1 is 0. 3 plus 4 is 7. 1 plus 16 is 17. And then we'll do this row operation. Negative 2 times 0 plus 1 is 1. Negative 2 times 1 plus 2 is 0. Negative 2 times 4 plus negative 3, so negative 8 plus negative 3 is negative 11. And negative 2 times 16 plus negative 5, so negative 32 plus negative 5 is negative 37. Okay. So notice we're definitely not done with this matrix, but if we were solving it, we're almost done actually, because this is what it should be, this is what it should be, and then we would just need to move on to this one. Okay. Notice I didn't ask you to do that, but I'm just saying. All right, because the purpose of getting a reduced matrix is obvious in the next problem. So notice this is a fully reduced matrix, and the benefit is that it gives us what the values of x, y, and z are. So here we would read this as x equals negative 4. Here we would read this as y equals 5. And here we would read this as z equals 3. So the solution is going to be written just like you would a two-part. It's actually called an ordered triple. So it's negative 4, 5, 3. Okay, so you probably will have at least a question where you have to solve a two-variable system using a matrix. So we're just going to remind ourselves of the pattern that we use, because you actually do the same thing in the same order every time. Should be brackets around there, sorry about that. All right, so the first thing is I really want this to be a 1. Okay, but notice there's a 1 here, right? So what I would suggest doing is a row swap. So row swaps aren't maybe the most common operation, but they are quick and effective. So notice we got the 1 just where we wanted it. Okay, so now we're good here, and now we want this to be a 0. Remember, you fix each column in order, but then you always do the 1 first followed by the 0. Okay, so I'm going to do negative 2, right? I want to add a negative 2 to this 2. So I'm going to do negative 2 times row 1 plus row 2, and I'm going to make that the new row 2. Okay, which means row 1 is not changing. So negative 2 plus 2 is 0, just like I wanted. Negative 2 times this plus this, negative 6 plus negative 1 is negative 7. Negative 2 times 11 is negative 22, plus 8 would be negative 14. Okay, so just what I wanted to happen happened to that column, right? That column looks good now. So now I move on to column 2. Specifically, this number, I want it to be a 1. So remember, you get zeros by adding the opposite sign. You get ones generally by multiplying by the reciprocal. So the reciprocal of negative 7 is negative 1/7. So think about dividing by negative 7. So I'm going to get a 0 and a 1 and a 2 there. So I'm actually almost done. This is good, this is good, this is good. The last thing is this one. I really want that to be a 0. So ask yourself, what could I add to 3 that would make it a 0? And the answer is negative 3. So I'm going to do negative 3 times row 2 plus row 1, and I'm going to send that to row 1. Notice we never add just a number by itself. You always add a multiple of another row. So row 2 is not changing because row 2 is actually done if you think about it. Okay, we already know y is 2. So then negative 3 times 0 plus 1 is 1. Negative 3 plus 3 is 0. Negative 3 times 2 is negative 6, plus 11 is 5. So we have the reduced matrix, and our solution is 5, 2. Okay. So make sure you know how to come up with your row operations. That's probably the biggest thing. It's one thing to follow row operations that are given to you. It is another thing to do the row operations yourself. All right, so let's move along. The next two are kind of similar problems. So again, let's do a row swap. So that's going to give me 1, 2, 0, and 2, 6, 4. Okay. So I want this to be a 0. I'm just going to start circling the number that's changing instead of necessarily writing in what it's going to be. So I'm going to need -2 times row 1 plus row 2. And I'm going to send that to row 2. So row 1 is going to stay. And then I've got -2 plus 2, which is 0. That's what I wanted. -2 times 2 is -4, plus 6 is 2. And then -2 times 0 plus 4 is 4. So now I move on to this guy. Okay, using the reciprocal, I'm going to make that a 1. So I'm going to do 1/2 times row 2. So row 1 is not changing again. And I'm just going to get 0, 1, 2 there. So I'm pretty close. Now I just need to tackle that guy. So I would make that a 0 by doing -2. So it's -2 row 2 plus row 1 this time. And I'm going to send that to row 1. So row 2 is set. So I'll pull that over. And then I'll do -2 times 0 plus 1 is 1. -2 plus 2 is 0. And then -2 times 2 plus 0 would be -4. If you're ever going along in this process and what you already fixed messes up, then you did something wrong. Okay, like this method is structured so that it doesn't ever mess up what you already spent time fixing. So just kind of keep that in mind. All right, so let's look at 30. We're on the home stretch. All right, so notice a row swap's not going to help us here. So we're just going to have to find another way to make that a 1. Okay, we can always use the reciprocals. So that's what I'm going to do. I'm going to do 1/3 times row 1. So think about row 2 not changing, right? And then row 1 is basically just dividing by 3. So I get 1, -1, 1. Okay, so now I move on to that guy. So I'm going to do 4 row 1 plus row 2. And I'm going to send that to row 2 because I want to get rid of a -4. So row 1 is remaining constant. 4 plus -4 is 0. -4 plus 4 is also 0. It's kind of strange, right? And then 4 times 1 plus -4 is also 0. Okay, so notice that we got this unusual row. We have 2 types of unusual solutions. They are no solutions and infinitely many solutions. All zeros means infinitely many solutions. So I want to see this, and then I want to see a description. So it's basically any point on the line x minus y equals 1. Notice, where did I get that x minus y equals 1 from? I literally just read that line. Okay, so this would be x minus 1y equals 1. And so it would be any point that follows this format. Okay, so the last 3 problems are matrix problems, or at least I kind of set them up to be, where you have to come up with your own equation. Okay, so let's look at 31 first. So we have an amusement park that only holds 1,000 people. I guess this is pre-COVID, right? And then we have like how much the park charges, right? So we have 2 equations we can come up with. So I'm going to use C for children and A for adults. Okay, so I know that there are 1,000 people total in the park. I just don't know how many are each, right? Like I don't know if it's like 500 and 500, or is it, 100 and 900, or any other possibility. So then it's $15 for every child. Okay, and I'm going to add that to $25 for every adult, and the total was $19,500 on this day. So notice the only change from what we have been doing is, well, really twofold. One, we had to come up with our own equations, and two, these numbers just so happen to be a little bigger, but the process is the same. Okay, I still want the pattern to be 1, 0, 0, 1 over here. So this is good, so I'm going to move on to that. Okay, so I'm going to do negative 15 times row 1 plus row 2, and I'm going to send that to row 2. So row 1 stays the same. Try to squeeze it in. Negative 15 plus 15 is 0. Negative 15 plus 25 is 10. And then negative 15,000 plus 19,400 would be 4,500. All right, so look here, we're done there. So now I just move here. Now remember, I wouldn't want to do a row swap because it would put the 1 where I'd want it, but it would mess up this over here, so I don't want to do that. So I am going to use the opposite sign, so negative 10 row 1 plus row 2, and I'm going to send that to row 2. So row 1 staying the same. Negative 10 times 0 plus 1, negative 10, where am I at? Oh, I messed up, right? I don't want a 0 there, right? So what I want is a 1. So don't be so hasty like I just was that you make a mistake. I guess all my whiteout pens are just going to not work today. All right, we found a winner. All right, sorry about that. I just got hasty and skipped ahead, right? This is not supposed to be a 0 like I was trying to make it. It's supposed to be a 1, right? So I actually want to do 1/10 times row 2. That's the change I actually want to make. And think about just dividing by 10, right? So this will be 0, 1, and then 450. And then last but not least, we really need this guy to be a 0. So I'm going to do row 1 minus row 2, and I'm going to send that to row 1. So 1 minus 0 is 1. 1 minus 1 is 0. And 1,000 take away 450 is 550. So then you just go back and look at what you listed first. So notice there are 550 children and 450 adults. Notice that it definitely works for the 1,000 people in the park thing, right? And you could also check it for the money thing. You could do 550 times 15 plus 450 times 25, and you would get that 19,500. All right, so number 32 is similar. You have to set up your own equations. It's just that we are talking about finance, and we have a little bit uglier numbers in this one. Okay, so they have $10,000 to invest in bonds and stocks. So my first equation is usually a simple one. I don't know how much of each I have, but I know that bonds and stocks together needs to be 10,000. Okay, but then we also have how much interest they earn, right? So you need to make sure you know how to change percentages to decimals, right? So 6% means 0.06. So bonds are making 6%, so I'm going to say 0.06 times B. And stocks are making 12%, so I'm going to say 0.12. And when I add those together, the total interest is 1,050. So let's set up my matrix. 0.06, 0.12, 1050. Okay, so before I start trying to really force this to be anything, I'm going to try to get rid of these. Like, I don't really like decimals, and I don't think that probably you do either. So what I'm going to do very first is I'm just going to try to move the decimal place twice. In other words, I'm going to multiply row 2 by 100. Because that's going to give me much more pleasant numbers to look at. And remember, I can do anything I want as long as it's one of the 3 row operations. So I can multiply a whole row by any number I want. So notice if you do that, this is going to be 6, 12, and then 105,000. So notice, like, this is so much easier to look at than this, right? So now I'm going to proceed and I'm going to do my stuff, right? So I'm going to change that to a 0. So I'm going to do -6 row 1 plus row 2. Send that to row 2. So row 1 pulls over. So -6 plus 6 is 0. -6 plus 12 is 6. And then just be careful, it would be -60,000 plus 105,000. So that would actually be 45,000. You could use your calculator on numbers that big. But notice, good, right? So next is that one. So I'm going to do -6 times row 1 plus row 2. And I'm going to send that to row 2 because I really need to cancel that 6 out. So my row 1 is steady. -6 times this plus row 2. So I actually want, hang on a second. All right, so sorry, I'm losing my train of thought. So this is going to stay -6 times row 1 plus row 2. And sending that to row 2. So I want to do, this is going to be 0, right? This is going to, I'm doing it again. No wonder, I'm looking at it like, why doesn't that look right? And the reason it doesn't look right is because I did the same thing. So it's the end of the day for me. That's all I can say. All right, so don't make goofy mistakes like I'm trying to make. I knew it really didn't look right because something wasn't adding up. So what I want to do is make that a 1. So I don't know why I keep making that mistake. Normally I don't do that. I'm not really sure what my deal is. But anyway, so divide by 6 and I get a 1 here. Divide this by 6 and I get 7,500 if you use your calculator. So then last but not least, now I want to change this guy, right? So maybe I won't mess this one up. So I want to do row 1 minus row 2, and I want to send that to row 1. So I've got 1 minus 0, which is 1, 1 minus 1, which is 0, and then 10,000 minus 7,500, which is 2,500. Okay, so that means I have 2,500 in bonds, since B is what I listed first, and I have 7,500 in stocks. So notice, like, I keep making the same mistake, but the reason, by the way, that I knew something was off is because I was about to mess up what I'd already fixed. So if you're finding that, then you're probably making an error like I just did. So maybe go back and make sure, am I trying to get a 1 or am I trying to get a 0, and make sure you're not confusing the two. Okay. So that's what kind of keyed me in on I was making some sort of mistake, because it was about to screw up my first column, and that's something that shouldn't happen. All right, so last but not least, okay, let's look at 33. So we have 3 variables, okay, and we have to try to figure out what they each are, right? So we are going to have usually 3 equations if we have 3 variables. So we have children, students, and adults. So the first expression that I know is that when I add up all the people, all the 3 groups, I have 900 people. Okay? And then kind of like number 31, I also have a ticket price, right? So I have 4 for every child, 6 for every student, and 8 for every adult. And when I charged that much for everyone, I made $4,400. So the last equation is going to be found from the second sentence in the problem. Okay, it says at a certain screening with full attendance, there were twice as many children as there were students and adults combined. So what that means is children was equal to double the students and adults combined. That's how you would write that. Okay, so children is twice students and adults together. Okay, but what you're going to want to do with this is you're going to want to make this be in the same order as this. So you're going to want to not only distributive property the 2, but you're also going to want to move them over to the other side. So what you end up getting is C minus 2S minus 2A equals 0. So trust me on it, but if you distributive property that out and then you subtract the terms over so that you're in CSA order here, then you'll get the same thing as I just got there. All right, so let's go ahead and write out our matrix. And then we've got 1, -2, -2, 0. We had to rewrite it like this so that we would be able to line it up like we did the rest of the matrix. Okay, so remember, 3 variable matrices are longer than 2 variable matrices, but the process is very similar. Okay, we're going to start with column 1, we're going to fix that, move on to column 2, fix that, and then move on to column 3. Okay, notice the 1's already good, so I'm going to start here and here. So we're going to do -4 row 1 plus row 2 and send that to row 2 because a -4 plus a 4 would be 0. Okay, here I want to get rid of a 1, so I'm going to do negative row 1 plus row 3, and I'm going to send that to row 3. So notice what is not changing is row 1, so pull that over. And then I always do the easy one first. So -1 plus 1 is 0. I'm going to do row 3 first. -1 plus -2 is -3. -1 plus -2 again is -3. And then -900 plus 0 is -900. -4 times row 1 plus row 2, so -4 plus 4 is 0. -4 plus 6 is 2. -4 plus 8 is 4. And then -4 here would be 3,600. It'd be -3,600 plus 4,400 should be 800. Okay, so in that step, notice we set column 1. We're good to go on column 1. Okay, so now we move on to column 2. Specifically, I start here because that's where I want the 1 to be. So I'm going to do a half times row 2 because 1/2 is the reciprocal of 2. So notice, row 1 is not changing, and neither is row 3. The only thing that is changing is we're halving all of row 2. So it's going to be 0, 1, 2, 400. So I'm good there. So now I move on to those 2. So I need a -1 here. So I'm going to do negative row 2 plus row 1, and I'm going to send that to row 1. And then I need a 3 here. So I'm going to do 3 times row 2 plus row 3, and I'm going to send that to row 3. So the only row not changing is row 2. Notice when row 2 is not changing, I tend to use row 2 to change the other 2. Okay, like in other words, I'm using row 2 to change both rows 1 and 2. So -0 plus 1 stays 1. -1 plus 1 is 0. -2 plus 1 is -1. And -400 plus 900 is 500. 3 times row 2 plus row 3. Notice these are a bunch of zeros, so it's going to stay 0. 3 plus -3 is 0. 3 times 2 would be 6, plus -3 would be 3. And 3 times 400 would be 1,200, plus -900 would be 300. Okay, so notice, these are tedious sometimes problems, but we are just slowly getting the pattern to be what we want. Now I fixed column 1 and column 2. Okay, so lastly I move on to column 3. Okay, so I want that to, of course, be a 1, so I'm going to do a third times row 3. So rows 1 and 2 are not being changed. So I'm just going to pull those over. And row 3 is going to be 0, 0, 1, 100. So by the way, I actually know there's 100 adults now. Remember, A is the number or the value that I listed last. But let's figure out how many children and students there are also. So last but not least, I need 2 instructions. I need to add this to something. So I'm just going to do row 1 plus row 2, or sorry, row 3. And I'm going to send that to row 1. Okay, because notice if I add them, I'll get 0 just like I want. Okay, and then to get rid of this, I'm going to do -2. So it's -2 row 3 plus row 2. Forgot where I was for a minute. And I'm going to send that to row 2. Okay, because row 3 is not changing, right? In fact, row 3 is finished. We already know the value for row 3. So row 1 and row 3 together is 1, 0, 0, 0. -1 and 1 is 0. 500 and 100 is 600. So, by the way, we should be able to guess what goes here because we have to have 1,000 people total, right? And we already have 700, so this better be a 300, and let's see if it is. So negative 2 times 0 plus 0 stays 0. Negative 2 times 0 plus 1 stays 1. Negative 2 plus 2 is 0. And then lastly, negative 200, not 1,000 people, it was 900 people. So negative 200 plus 400 is 200. Because I was like, whoa, I'm not getting the answer that I thought. But remember, it was actually supposed to be 900 people. I think I was thinking of 31, which was 1,000 people. So in the end, go back to the beginning and see what you did in what order. But it's 600 children, 200 students, and 100 adults for a total of 900 people. And notice, like, you could check the money thing, but also notice there's double the amount of children than there is students and adults combined, right? Like, students and adults combined is 300 and 600 is double that. Okay, so just make sure you're practicing these problems to get ready for your upcoming test.